Hello guys, so today we are solving this problem. Find the power of k size subarray. Okay, so what is happening over here is like you are given an array of integer nums of length n and a positive integer k. So the power of an array is defined as, okay, so its maximum element if all elements are consecutive. Okay, so like this, for example, you take this subarray 1 2 3. So all elements are consecutive, right? They are increasing by 1. So 1 2 3 like that. They are in ascending order. That is one case. And whatever is the maximum in this sequence. So for size k, let's say k equal to 3. So in this case, what is happening is this guy 3 would be the maximum. So we have to this 3 would be basically the power of that subarray. Okay. So return the array of the results of size n minus k plus 1, where result I is the power of the nums I. So whatever, for example, let's take this example. For example, here k is equal to 3 and this is our nums array. So what would be the, let's say this is our answer array. So see here, this is our first window of 3 size, right? And what is the maximum here? Maximum is 3. So we will put here 3. Okay, now we will go to the next set of 3. So we will start from here till 4. This is another set, and all of them are increasing order, consecutive. 2 plus 1 equal to 3, 3 plus 1 equal to 4. So this is also a valid sub-array of size k. So what is the max here? Max is 4 here, so we will put here 4. Now we will start from here. See here, so we will go 3 4 3, right? But see here, the sequence is broken here. 3 plus 1 4, but 4 plus 1 it is not 5, but it is given 3. So what we'll put here, whenever there is a broken thing, we will put it as minus 1. Okay, then we will come to the next set of it. So we will again go for the 3 set. This is 4, then this is 3 and 2. So this is not the proper increasing sequence by 1. So here also we have to put minus 1 only. Okay, then we will come to this 3. Okay, this 3 up to 5. This is also not the increasing one, right? So we will put here also minus 1. So guys, remember our start point will be traversing only till the n minus kth index, right? If n is the size of it, then like here up to this size only it would be n. So the start point of this window would be from n minus k. It cannot go further more, because anyway then it would not be the size of k. Okay, so this is what we have to do. Now I will tell you how to approach this problem. So let me tell you what is my approach. So first of all, we will create an array. That array would be of n minus k plus 1 size, right? Because we need, it's given in the question as well. You can see here. Let me go here. See, we have to find the n minus k plus 1 size, because last window would be kept as it is. That is why it is clearly mentioned. So n minus k plus 1 size array we would be creating here. So let's check this example itself. So what we would start is, we will have it 3 variables. One is start variable, okay, one is the end variable, and one would be the previous variable. So start equal to, we will keep it at 0, and the end also I would be keeping 0, and previous also I would be keeping as of now 0 only. Okay, and what would be our answer array? So our answer array would be something like this. So what is the n here? So 3 and 3, 6 plus 5, 7. So n is 7. So n minus k plus 1. 7 minus 3 plus 1. This would be 5, right? So we have to have an array, answer array of size 5. So suppose this is our 5 size array. Okay, like this, 0, 1, 2, 3, 4. Okay, now what we will do is, we will start from here. So see here, this is our start point. Okay, so our start point can traversal only up to this, right? So it can go only till n minus k inclusive. Okay, so n minus k would be the last point where this guy start can traverse. Okay, so what is the n minus k here? N is our 7, and 7 minus 3, so up to 4 index. Okay, so index number 4 till our start value can traverse. So it is start equal to 0. So see here, we are at here. So what is the previous? Previous was also equal to 0. So end. So what is end? End we will basically start with 1. Sorry, it should be 1, not 0. So now we will check this condition, that hey, this end is matching with the condition which is sitting at 0. So see here, end is here, okay, and the previous is at here at 1. So we will check that previous plus 1 equal to this and 1. Yes, see here at previous, which is 0, it is value 1. So if we do previous, so nums of previous, so what we are checking, nums of previous plus 1 equal to nums of end. This is what we are checking. Nums of previous plus 1 should be equal to nums of end. Okay, this is what we are checking throughout, nums of end, like this. Okay, so we will check this. So see here, this is matching condition, so val and good. So we will increase our previous, so our previous would now become 1 and our end would become now 2, right, because we are coming to here. Okay, so now we will again check that, hey, is this num of previous plus 1 equal to this guy 3? Yes, this time also. So 2 plus 1 equal to 3, right? So this is also valid consistent. So our new previous would become 2 and end would be becoming 3. But before going to there, we have to check whether is it a size k. So what we will do is, whatever we have the end, okay, so end minus start, we started from start, right? So end minus start plus 1 should equal to k. So see here, where is the end? End is at 2. So 2 minus 0, 2 minus 0 plus 1, what this value? 2 minus 0 plus 1, this value is basically 3, which is also equal to k. That means we found a window of size k. So we found this window. So if we found everything is matching, so far we found this matching condition, then we were checking this condition. So that means we found a sequence of size k. That means this guy, the first guy, at start point we have to put the value as the whatever is the maximum. So what would be the maximum? Maximum would be the end value, because anyway we are finding a sequence. So last value, the one sitting at end, should be the maximum value. So what is there? It is 3. So we will put here 3. Okay, and we will now point to this guy. So we are done here. Now what we will do? We will increase, after getting one size window, we found the first k size window, right? So then we will start our k. So we will increase it by 1. Okay, so our start would be now pointing from here. Okay, now we will again similarly we will repeat it. So see here, now our end would become what? It would become 3, right? So now check here. So what is there at 3? At 3 it is 4. So 4. So see here, previous is 2 here. Previous index is 2. Okay, so this is 3 plus 1 equal to this guy. So that means again this condition is satisfying. So we found another condition. Now again we will check that, hey, is this true? So yeah, right, at end it is 3. Correct? 0, 1, 2, 3. So yeah, we will write here 3 minus what is our start? Our start is 1. So 3 minus 1 plus 1. So what is the size here? Size is again becoming 3. That means we found another valid window. And if we found another valid window, we will again put what is the max here. Max would be the end value. So we will put here 4. Okay. Now we will again increase our start point. So our start point would become now 2. Okay. And end would be anyway coming to this guy. Or this guy. Right. So end would be become now 4. And our previous would be become anyway 3. Okay. Now we will again check here. So see here, this is 4, right? At index 4, what is the value? At index 4 it is 3. But previous value it is 4. So condition is not matching. So see here, whenever the condition is not matching, what we will do? From start point. So start is 2, right? Right now we have a start equal to 2. So starting from 2 till the end minus 1. Okay, we found end here. We found the end at here 3. So we will have to put these many values 3, 4. Right? These many values we have to put as minus 1, minus 1. So we will put here what it would be. It would become minus 1. And this next value window also going invalid. So we will make here also minus 1. Okay, now finally we are at here. So see here, what is happening over here? 3, 2, 5. So anyway, when we are done with this, our start value would be come to the value where end minus 1 was there. So our this start value would be end. So our end would be what? It would be it is 4, right? 0, 1, 2, 3, 4. Yeah. So this would become now 4. Okay. So whenever we are doing this kind of resetting, our this end would be again like we started here initially. So this would be become our end would be become 5, and the previous would become 4 only. just the way we started everything, right? Because everything is resetted here. So start was equal to previous, and end was start plus 1. We initially we started end equal to 1, right? So similarly we are doing here now, but by that time more than 3 we cannot go, right? So see here, when we are starting here, okay, so at here we will check that, hey, is this end the value? So at end what it is index 5. So it index 5, this is 2, which is previous value is 3. So our sequence is broken. So if sequence is broken, that means we have to put here -1. Okay, now we just cannot go further right side, because start is anyway only up to this guy, n minus k guy. So we are coming out of it, and we have filled the whatever the answer, we have to return this one. So this is what we are doing. Now let me show you my corresponding code to you. This is my corresponding code. See here. So initially what we are checking, if k equal to 1, that means the sequence itself of size 1, means every element, every number is in a sequence of size 1, right? In that case we are returning the nums itself. Okay, otherwise what I am doing is here I am creating one answer variable of n minus k plus 1 size, and then these are some usual variable names which I would be using. So see here, while start is less than n minus k, less than or equal to, so this is the last value where up to which it can go, right? See here, we came here only till here at this 3 index, right? The value here. So same way we are making that n minus kth is it should go only till n minus kth value, and end is less than n. These are the conditions. Then I am going here, if nums end equal to nums previous plus 1, then anyway we found the value. So it's a matching sequence. Then inside it we are checking that, hey, whether we reached to a k size window. If it is a k size window, means end minus start plus 1 if equal to k, then what we are doing, we are we are putting this value, answer p value, at the index p, we are putting this max value which is at end, because if we are finding a sequence, that means the value sitting at end should be the maximum value. And then we are increasing start plus plus, because we need to increase this guy, right? If we are done till here, we will point to this guy, next guy. So for that reason I am doing start plus plus. So this is only when this thing is matching, and then inside it we are checking that if we found a window of size k, then we are increasing. Otherwise anyway we are doing this previous equal to end and end plus plus. I am doing this because I need to maintain a previous variable to compare them. Okay, so this is when the sequence case is correct, is true. If this case is not, we will go to the else part of it. So if we are going to the else part of it, see here, we are checking here, the else part means the sequence is broken. Okay, so what we will do, while this start is less than end, okay, and this p value is definitely within the limits of answer, then what we are doing, we are putting the values equal to -1 that many times till the start becomes equal to end. Okay, so then when we are coming out of this loop, what we are doing, we are making end equal to start plus 1. Okay, so next set of window would be start from here, and previous is equal to start, just like we started here, right? We give this start equal to 0, previous equal to 0, and end equal to 1. So same set of things are starting when we are at here, coming out of this loop. And same way we will be keep on going till the time this while loop runs. So when this while loop would be start, when we are reaching to the last valid location of start, so that it would be maintaining a k size window. After that we would be stopping it, and then finally we are returning this answer. So let me try to execute this code. So I am running it, okay, and let me try to submit it. So yeah, so it is 100% faster because we are not using any extra space. Though time complexity is O of n, we are doing only single traversal, and space complexity is O of 1 because we are except few variables, we are not using any extra space. So thank you for watching this video. If you guys have any concern, please make a comment over there.